So I'm Professor Kola, and I'm the faculty coordinator for the Micro and Nanoengineering track. And I'm going to tell you guys a little bit about it today. So, we'll be kind of informal, so if you have any questions when I come across a particular slide, just feel free to interrupt, and I'll do my best to answer the question. So micro and nanoengineering, I want to define that for you first. Some of you are probably familiar with nanotechnology, some things that pop up in the news every once in a while. So the way we look at it is that micro and nanoengineering is using the phenomena that exist at the micro and nano scales in systems at real scales to try to figure out how those phenomena can make things more useful and enable different capabilities in functional systems. So we decided to put together this concentration to help you all, because as engineers, we go through, we get our disciplinary knowledge, and we come out of Georgia Tech pretty good with that. So we thought, well, what other skills would a student need in order to come out and be successful in grad school or industry or whatever you want to do in the field of micro and nanoengineering? You know, and there's some unique phenomena at these scales that require more in-depth, basically it's more in-depth chemistry and physics in order to appreciate and to do things at that length scale. So some of the things that micro and nanoscale phenomena and technologies are enabling: energy is a big area, health is a big area, information technologies, all of these things, information technologies, laptops, smartphones, those systems have been micro-engineered for years. Transistor dates back to the 1950s, but we didn't really start using the buzzwords until maybe 10 or 20 years ago. But there are many more, plethora of different applications based on micro technology that was developed for chips that are now being applied for other systems and applications. All right. So in a nutshell, one would need a strong foundation in chemistry, physics, and your disciplinary core. So unlike some concentrations that may be focused on mechanics or thermal, when we talk about micro and nanoengineering, it's still engineering generally. So what you end up bringing to it is your disciplinary expertise. So you know, I'm in mechanical engineering, someone else could be in electrical engineering. What's the common language that we will speak? Well, the common language will be a more in-depth understanding of chemistry and physics, so that we see when our relative disciplinary theories and approaches break down and need to be modified to treat materials and systems at those scales. So this is an example that I love to show because it excites me. I'm actually going up to visit this company this afternoon. They're in New Hampshire, and they make large-scale sheets of carbon nanotubes. And you can see the reactor at the top and the workers down here with this sheet of nanotubes. It just looks like a black sheet, but if you look at it under the microscope, you see billions of carbon nanotubes that are entangled and aligned to create this sheet. So this is, to me, the heart of what micro and nanoengineering can do for us in terms of potential. New phenomena, these carbon nanotubes are a new material, they have new phenomena, but not, as engineers, we just can't focus on the phenomena. We have to think about how do you scale it. Because at the end of the day, to do things that are useful, you have to demonstrate performance and scaling of any of these phenomena that we work on. All right, so that's it. What is it that you can do? All right, so you're all here, you're interested in micro and nanoengineering. What can it do for you? I tend to be cautious about framing career paths, just because I think that, especially being at Georgia Tech, when you finish here, the world is your opportunity, and there's so many other things you could do besides the traditional. But I took a shot here. So if you just come out and you want to do industry, say you have a great idea that you work on, maybe it's Luke's nanoengineering project from my class that he turns into a senior design project, and he gets some venture money and wants to start a company. That's what attracts a lot of people to micro nanoengineering. That's what attracted me to the field. I was someone that was very interested in starting my own company, so I wanted to be somewhere where I could see new technologies and be at the frontier. Established companies as well. they're looking for new edges. They're looking for new technologies to integrate into their product portfolios. So if you go out to industry, hopefully if you finish this track, you learn something, you'll be able to contribute to industry in that way. Maybe you decide to go on to a master's degree or PhD degree. So you go to grad school. I'll talk about the courses in the track in particular, but there's an option to get credit for undergrad research towards the track, and that's there to help students use the coursework in a practical hands-on lab experience and build something towards being able to go on to an MS or PhD. All right, so I have this actually broke up the grad school into grad school then industry, because I think the same thing applies. If you look at a lot of the companies that are startup companies in the nano micro field, a lot of their executives have PhDs. You know, people often say, you know, it's not a good idea to have a science PhD as the CEO. That rule is often overlooked when it comes to micro and nanotechnologies, because you really need someone who can talk the language. And part of the concentration is giving you the tools to be able to speak the language of the micro and nano engineer. So the other option is if you go into grad school and you really like studying and mentoring and writing papers and things like that, then there's always being a professor or going into academic research. There's government research. So right now that means either doing research, you know, Oak Ridge National Labs or someplace in the DC area on a particular technology, or it could be a combination of working on policy. One of the big issues in micro nano systems now is that as the technologies start to scale, it becomes more important to think about the effect of that scale on human society in terms of health, environmental, and unintended consequences. So there's a great effort and need for more thought into the policy arena as well. And there are several fellowships, just like there are fellowships, scholarships for students going to grad school for pure science and engineering study. There are fellowships and scholarships available for policy internships. My wife is a chemist. She actually spent some time as a policy fellow in DC doing the things that I'm talking about. And other. So there are many other things that you can do. I have so many friends that I went to school with that don't do anything related to engineering now. Maybe you go to business school, that's kind of a common track. At least now you know you can speak the language of the nano micro engineers when you want to collaborate to start new ventures. Maybe you just want to be interesting at cocktail parties. Maybe you come from a wealthy family and you just want to walk around and be able to toast and talk about micro and nano engineering. You can do that also. You'll impress people. So what are some of the big questions, if you will? Well, one question is, can micro nanoscale phenomena be used to overcome traditional limits? That's what everybody's looking for, an edge. So micro nanotechnology, what edge can it give you? Short answer is yes, it can. But even more fundamentally, for those that are really interested in pure understanding, excuse me, what are these new limits? So if we develop materials and systems at the micro nanoscale and we overcome limits, then we have an intuitive sense that there will be new limits. Maybe there won't be. But these are the open questions in the research field that a lot of faculty here at Georgia Tech address. Right? And I alluded to this earlier, but the grand challenge, you ask 100 people, you may get 100 different answers about what the grand challenge is. But the one that I wanted to present to you is this challenge of demonstrating technology performance and scale. Right. We've been working in the micro nano science and engineering fields for about 20 years with the coinage, maybe longer than that without calling it what it is. But the idea of getting more commercial products and making more use out of this technology, to me, really is the challenge to the engineer. Because the engineer is the one that's going to look at demonstrating, maintaining performance, and scaling at the same time. And if you start a company, if you're somebody who's leans that way, you're going to have to be able to demonstrate to potential investors that you can attack both of those things simultaneously. So this is crowded. This will be on the website for you to look at. But I just wanted to give you a snapshot of the faces and names of people in mechanical engineering here at Georgia Tech that do micro and nano engineering. And a lot of these people, I know pretty much everyone on this list, go into micro and nanoengineering for various reasons. Some people are more interested in just understanding these limits that we talked about. Where are they? Can we define new ones? Can I push the edge? Some people are interested in just advancing technologies, and they want to pull from micro and nano to improve the packaging of organic light-emitting diodes, or improve carbon capture. So everybody has different interests, but they work in this area and bring together the same set of skills and tools, which are their engineering discipline, mechanical engineers, and a more fundamental understanding of how chemistry and physics are relevant at the micro and nano scales. Right. So we summarize the topics, and these are what I consider to be major focuses at Georgia Tech around micro and nano research. We're really looking at synthesis and characterization of materials, which is very important. So people are trying to make new materials based on theory. Some people do it Edisonian. I happen to be a little bit of both. And you just try to put things in a pot sometimes and see what comes out. But you have to characterize it, regardless of how whether it's theory-driven, intuition-driven. At the end of the day, whatever you make, you have to characterize to demonstrate its improved performance. And then the properties of materials. There are a lot of people who just focus on properties, wanting to understand, enable new properties. Modeling and simulations. We have a lot of people at Georgia Tech inside of ME and outside that do a lot of really good leading edge modeling and simulation of materials. One of the grand challenges out there is can we create through simulation material design that is closely matched with reality. It's not easy yet. We haven't really reached the capability to assemble in a simulation materials and study and run experiments so that we don't have to spend money and time and resources in real life making these materials and measuring every single one. So that's a big challenge out there. Novel devices and systems, very broad, but everybody's looking for an edge, like I said, to figure out if they can solve a problem using these phenomena at the micro and nano scale. And then medicine and biotech. So I believe there's going to be a track. If there's not one already, there will be one on bioengineering. But nano kind of fits in that too, because if you think about things at the biological level, they tend to be on the micro and nano scale, molecules and cells and things like that. A lot of cool stuff. A lot of cool stuff going on. All right, so I encourage you, the best way, I'm not going to be able to sit here and tell you all the cool stuff that goes on. If you really want to get engaged, I do encourage you to think about, if you're going to sign up for this concentration, taking a research credit, looking at these faculty members, seeing what they do, trying to figure out what your interests are and how they gel with what they do, and learn something. All right, so this gets to the meat of the concentration. These are the courses that we've laid out for you to turn you into micro and nano engineers. So the way the concentrations are set up, there's a required design course. So the design course for this track is energy systems and analysis design. And the reason we chose this is because a lot of the grand challenges that understanding micro and nano address are related to energy or some sort of systems that are very analogous to how energy systems work. So once you learn how to balance thermo and fluid heat transfer in an energy system in consideration of economics, a lot of those skills apply to general performance and scale of micro and nano systems. So this will be up there. I'm going to step you through the courses now individually. So the big picture is there's one required design course that has a prerequisite of heat transfer, so something you would take later in your progression. And then you have to choose 4 electives from this large list below. All the courses are 3 credit hour courses, and only 2 of the ones in this list below are ME electives. So there's a lot of options outside of mechanical engineering. And the minimum that you would have to take would be 2 courses that are outside of ME at this time to satisfy the concentration. Now, I'll say at this point that new courses are constantly being proposed and thought of by faculty. So this is not a static but a dynamic picture that's bound to change. So like I said, the design course is required for the track, for the concentration. And here, energy systems analysis and design is what I said it is. has a prerequisite of heat transfer, so I won't spend too much more time on that. There's a course that I'm teaching this semester that one of your audience members is in, and it's Nanoengineering Energy Technology. So this is a 3-credit-hour ME elective designed to introduce you to terminology and concepts at the micro nano scale and have a hands-on project to use those technologies and those concepts to design something, design a new technology. So a prerequisite for this is going to be heat transfer moving forward. It was actually thermal this semester. There's another course that's being offered this semester on the fabrication and properties of nanoscale devices, another 3-credit-hour ME elective course. And it's an introduction to the fabrication and properties of nanoscale devices. So it's kind of like a survey, but it's a little bit more, so you go into a little depth into the fabrication techniques that are used at these scales. Prerequisite is thermodynamics, so something you could take in your junior or senior year. And it's co-listed in material science, so it has 2 instructors, 1 ME and 1 material science. All right, so the slide's going to get a little bit more crowded. Undergraduate research, I mentioned that. So this would be research guided by a faculty member that's doing micro nano scale research. Chemistry, so there's really, if you look at the big picture, you could get by with taking a lot of design and ME courses and system level and some survey courses, but there are options on the list for you to get a really in-depth, I guess, experience with chemistry and physics. So if you're thinking about going to grad school, if you really want to do something modeling or theoretically based, you might want to consider taking physical chemistry too. So it's a 3-credit course, goes over some basic quantum mechanics, bond theory, which is important, and statistical mechanics. Now this course has a prereq that's outside of the concentration. So this is a note that if you do decide to go this route, that there's an additional chemistry course, which is a good course, that goes over some electrochemistry, kinetics. Electrochemistry is used a lot in micro nanoscale systems for sensing and also for fabrication. A lot of metals and polymers are deposited through electrooxidation or electrodeposition. So that would be the progression there. You would take this prereq, and then you would move on and be able to take the physical chemistry too. Or, so that would be for the person that's interested in a more chemical side of the application space in the micro nano. So maybe somebody that's doing a lot of sensors, like I mentioned, or if you're doing more bio, where the chemistry is important. Another way to go would be to do solid state physics, where you're also going to get an introduction to a lot of the similar concepts that you would get introduced to in the physical chemistry too, but it's going to be more focused on crystal structure, properties of crystals, and so on. And there's a prerequisite for this course as well. So whether you take the chemistry or the physics route, you still have an outside prereq. And this prereq is the first introduction to quantum mechanics. So this one is going to tell you, about the quantum theory, give you some practice with simple examples of problems that you could solve in quantum mechanics. All right, so these are the courses that are outside of the ME, but are part of the list of available courses as well. So there's a special topics course in aerospace engineering, on micro renewable energy systems. There's a special topics on microfluidics and biomems and chemical and biological engineering. And there's one also in chemical engineering that is basically nanosystems from a chemical engineering perspective. So in a nutshell, if you're looking at the aerospace ones, you're going to look at a lot of energy systems that have something to do with aerospace that are micro engineered and they're renewable. If you look at the chemical engineering courses, you're going to be looking at things that deal more with the chemistry, deal more with the bio applications, the medicine, biotechnology applications, but also with catalysis and things that are related to artificial photosynthesis, for example. So you're going to get a lot of energy there as well, just more of a chemistry bend. I don't know why that popped up first. So there's an MSE course, nanomaterials, where you go over a lot of processing and properties. and then also a thin film material science course. And the first course in material science is special topics. The other one is a regular course that has MSc 2001 as a prerequisite for it. And then there's another MSc course on soft nanobio. So again, for the polymers and bio people interested in that area, that also has the same MSc 2001 prerequisite. So with that said, I'm going to wrap up, and I think we still have some time for questions. So hand it back.
First of all, can I find this work online?
So the question is, can he find the PowerPoint online? And yes.
And the other question is, on the second slide, you showed career paths and with industry established and startup companies. Yeah,
Okay.
so with respect to any electives, what products will these companies be related?
So for the career paths, you're thinking about relating them to the nanoengineering energy technologies and the fabrication of nano devices. What industries do they relate to? It's really broad. So in the nano devices course, you're going to be looking at applications that are relevant to food processing, to sensing, whether it's chemical agents for defense or sensing just in the household or environment, to energy, very broad. The nanoengineering energy technologies course will be focused more on energy technology. So it could be solar cells, could be thermoelectrics for waste heat harvesting or refrigeration, but generally energy technologies. So there are companies out there that are startups where you'll see the nano, micro in their name and you'll know clearly what they do. But there are a lot of big companies that are Raytheon, Intel, classic names that also do this, but they're not advertising it because it's not their core, but they're looking to integrate these systems. Question?
So once we complete all the requirements, we get a concentration show up on our transcript, right? Is it?
So the question is, once you complete the requirements, do you get a concentration on your transcript? And the answer to that question is?
The answer to that question is it's not there yet, but we're hoping it will be there soon. Okay? So if you would graduate right now, it's not going to show up on your transcript, but definitely put it on your resume. I mean, you can still do that, but we're working on getting it onto the transcript when you graduate.
Like next year? How about next year?
Next
so
year?
Well, I'm applying to places like say internship and research position. And I'd like to have it show up. Would be nice.
Even if it's not there, because I don't have an answer to the question, you can still highlight the courses that you take.
Right.
And I think that should speak volumes on its own.
Would there be any ECE-related industries? ECE and nanoelectronics related industries?
So the question is, will there be any ECE and nanoelectronics related industries? So the short answer is yes, if you're thinking about in relation to the applications and technologies that are being covered in the 2 ME courses. There are technologies that are related to electrical computer engineering technologies that are there. To really find, I mean, the courses aren't really going to introduce you to every company and industry that's out there. It's really just going to focus on kind of the fundamental applications with some examples. But this is where I encourage you, if you're going to be in the track, to be an active participant and to engage with grad students and faculty members through email or through your class to ask these questions. At office hours, great resources they are. So you tap into that, and there's a network at Georgia Tech, and you can find out many different options for industries related.
I have one more.
Yes?
What's the difference between, so like Micro and Nano is under mechanical engineering, but what separates this from material science?
It's a good question. When you go down to the Micro and Nanoengineering, like I said, you have a little bit more chemistry, a little more physics, you bring your disciplinary experience. Mechanical engineers deal in mechanical and thermal systems. So material science may be interested in how the crystal structure changes at the nanoscale. Of course, they're interested in applications too, but that's, everybody focuses on something. So within mechanical engineers, it's about systems. And one of the big points is that we, through microsystem and nanosystem engineering, start looking at materials as systems. You start building systems and being able to study and apply the systems understanding that you develop in mechanical engineering is what differentiates you within the discipline.
We need to swap over.
Swap it up? Okay. All right. Well, thank you. If you have questions and you're not in my class, then you can email me. My contact is easily available. So it goes for you that are watching the video as well.